think to conserve as much energy as possible, we're going to shorten this just for tonight because we're all jet lagged. It's going to be chain Siggy. It's much faster, just much easier. Okay. We're going to talk about chain Siggy, and this is going to be a little bit of a recap in case you didn't see the previous thing I did earlier today. But this is much more focused at like how do you actually build and like what kind of stuff did I run into that maybe will be helpful. So a teeny bit of refresher, but this is going to be really useful. So ultimately, what we want to do in this hackathon is send something to this sign message, which is on a smart contract, right? So there's a smart contract that all the examples are pointing to, so that will be really easy to find. And essentially, we're going to be sending something here with a certain derivation. And remember, this is basically the same thing as like a ledger, where you can have one ledger that has like, you know, more than trillions, I think it's at least trillions of different like accounts to it. So the really cool thing here is that you can also do this straight from your account if you want to. You can have a key on like Mike.near and you can call this sign. Or if you want to, you can also have a smart contract call that sign method. And then this is the chain signatures TLDR. So you start here with your account. And as we know, accounts also can have a smart contract on it. We're going to be calling sign with these three things, basically. And then here is where the magic happens. And it is live on testnet. So once you hit sign, you don't have to do anything. You're just going to chill, and it's all going to happen. And you'll be determining which one of these you want. So, and also notice here that we have 2 different Bitcoin addresses. So you're not limited to just like, okay, Mike.near can only have 1 Bitcoin address. That's not how it is. And then key derivation. Okay, so this is more of a primer of like how I was completely wrong in thinking about this entire project, and then how I kind of like figured it out partially at least. So key derivation, I think usually we're talking about like, okay, I have MetaMask, you have your seed phrase, and then that's going to get to a private key, and then there's a public key, and I think for many of us, that's like kind of the whole world. That's how it's been for like a really long time. MPCs are going to be different, where it's actually like not exactly that same kind of idea, and this is the part of the docs where you can learn more about the specifics of this. But the main thing to take away from this is like, you can kind of throw out the idea that like, you have to have a private key in order to sign something and get a signature. So that's like something to break in your brain if you haven't kind of had that realization yet. So these individual signatures from the multi-party computation, they kind of like add up. So the way I was saying it before is like, I just imagined in my head like, here's a signature from one of the MPC relayers, second signature, third signature. You squash all those together, and you actually get a signature. You don't get a private key, you get a signature. And there's more about this in the docs. This is like called additive key derivation. And as we can see that this is like, this is the part of the docs where we talk about how this is all happening. Okay, now this is my understanding, and there's a lot of people here who understand this better than me, so feel free to chime in. But the basic idea is this. We know that the MPC on testnet has a public key. Like if all of them were to combine, basically, it would be like they could sign a message that looked like, because it is, coming from a certain public key, right? Now this public key is like totally public in the sense that it should also be like implemented on like the client. So we're not like, this isn't like you don't have to query anything. Like all the examples will have the public key like hard-coded in there. That's supposed to be how it is. So you need to know the public key. You need to know like your own account, which is very easy because you'll usually just like log in with your Near account, and it's gonna know your Mike.near or whatever. And then a unique derivation path. This one, I would follow the examples. So don't get too caught up in like, am I doing the derivation path right? I would just say like, follow the examples and you'll be gravy. So with these ingredients, essentially, you can like figure out like okay, what is my public key for my Bitcoin account that like is going to get signed not by me actually, but it's going to get signed by this like a bunch of like relayers, this multi-party computation. Okay, is this are we good? Are we kind of following here? Awesome. So once you send to that sign method, the MPC is like looking at everything that happens on the blockchain. It's saying, okay, what happened, what happened, what happened? Aha, someone called sign. Who called sign? And so it's going to be able to know, this, right? It already knows its own public key. And then when you call sign, you also send in the derivation path. So it knows all these things, and it says, okay, so this person is asking me to sign like their Bitcoin address from Mike.near, blah, 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 right? Magical mathematics come in, and it signs it, squashes it into a signature, and then afterwards, it is basically gonna like lob you, what? Not the private key, remember, not the private key. It's lobbing you the actual like signature, okay? Now, little bit of, like, I had to reread this, but this is pretty important. And actually, ChatGPT will sort of get confused a little bit because ChatGPT is going to assume that you're not giving it a hashed message. Anyway, I'll talk about all this. So like, this is sort of pseudocode, but like, let's say this is a message that I can actually send to a blockchain. Who am I gonna pay? Erica. How much am I gonna pay? 8 Bitcoin. Memo, happy birthday. Yeah, so you take this bad boy, you like squash it up, turn it into a hash, right? It's sort of meaningless. It's gobbledygook. And then we're going to like send this and try to get this thing signed, right? So then the signed hash is going to be also something that doesn't make any sense. But these are the two ingredients that you actually are going to be. Yes, the MPC signs this, not you. And see, not you, ChatGPT, because it is going to get confused. It's going to say, wait a second, actually, you're doing this wrong. What you need to do, no. Like, so don't listen when it says that. So be very explicit if you're using ChatGPT here. So we're going to, send it, jet lag. So these are the two things, right? So we're going to basically like take these guys, and then we're going to be like, okay, throw into a ball, and then be like, okay, Bitcoin RPC, take those. And so this is what you like send. Am I kind of on track here? Okay, cool. So this is sort of like the workflow to have in your head, because this is sort of a new way of doing things. Most of the time in Web3, you're just like using the same functions from some library, and that you don't really get to know like kind of what's happening behind the scenes. So this is sort of what's happening behind the scenes. Now, I mentioned this in my previous talk, but I think it's really, really cool. It was like you're saying, like the goal is to like stretch the idea and like let's really play with this thing, right? Like what can we do? So I think one interesting thing is to like have a contract call the sign method. As mentioned before, like all near accounts like can have a smart contract if you want it to, right? So this is like Mike.testnet, and there's a perfect little cubby hole where you can just slide a smart contract in there. You don't have to, but you can. And if you slide a smart contract in there, then that guy can call the sign method. So either you can call a sign method, or your smart contract can call a sign method, and in either case, it's coming from you, right? Now, this makes it really interesting, because then your smart contract on Mike.testnet like can have any kind of custom logic, like. And we'll get to an example that Kendall came up with that I just realized how it works, or the idea today. Let's talk about some cool examples. So this one is near multi-chain, and this is going to be in the link tree, by the way, so you don't have to memorize this. This one is going to have a few different ways to interact with this. So great example right here. Mintbase, and I believe there's also a. After this, yes. There's going to be a Mintbase demonstration in Korean, which is awesome. If you don't know, Mintbase is just really, really innovating at a crazy breakneck pace in all kinds of ways. And yeah, they have a demo on testnet that works where you use chain signatures and you actually interact with OpenSea NFTs. It's like amazing. I've been trying to build like these examples, and I'm like, having trouble, and they're like, oh, hey, we have this thing like talking to OpenSea. Do you guys want to like use it? And it's like, yes, please. So this is just an incredible example as well. This is a third example that I'm going to show. Down here it says decentralized front-end approach. So what this means, and this is also something we used to call BOSS. So if you're kind of confused, BOSS, decentralized front-end, all this kind of stuff. Basically it means like, one of the cool things about blockchain is that you can say, all right, I want to send like $10,000 to this one smart contract, but like, man, I don't trust it. Well, you can find the source code, you can compile it yourself, and you can be like, yes, this is the exact same thing as what I'm sending it to, right? So you have this like assurance that like, okay, the smart contract is exactly this code, and it's not going to like take all my money or whatever. But for the longest time, we forgot that like when you're pressing that button to send $10,000, like that is just completely like trust, right? So the cool thing about decentralized front ends is you can actually go on the chain and be like, okay, so here's the button code and what is it doing? Okay, yeah, this is fine. So you have a combination of like the button that you're pressing and the smart contract that it's talking to are both verifiable. Like you can totally like make sure that everything's fine. Super cool. So this example is another way that we can interact with chain signatures. Chain Siggy. Here is a animated GIF showing essentially like, an Ethereum contract associated with Matt Lockyer's account. And then it'll say, okay, cool, you actually do have a balance. Who do you want to send it to? This is Etherscan. You get the idea. Really neat. So this is an example that we have in the link tree as well, which we're going to share. And then now, here is where I will attempt to talk about this, which I'm just now kind of realizing is amazing. So this is, think of this as like, you don't have to think about it as, like for a hackathon, just think about this as like a fun little smart contract that you deploy to mic.testnet, right? But this is gonna have like all kinds of like logic saying like, I want to derive an address on Bitcoin, but then I'm only gonna let this person access it, and then I can swap-a-roo and give it to someone else, which is a really interesting way of using this. So I'll kind of walk through this step by step. So here's a seller who says, we're going to deposit some, we're going to basically connect to a BTC account. A buyer is like, okay, I'm also going to be participating in this. And let's say that like this person is like, okay, here's a BTC account that is controlled, again, by the smart contract using logic. And I'm talking about, this isn't like crazy, this is like 15 lines of Rust or something. It's not hard at all. So the contract is the one that controls the derivation this time. So essentially we have, okay, two people are like, all right, we got this ordinal, I have it, do you want it? Yeah, I want it. And then, boom, like, essentially there's a whole bunch of lines here. Maybe the most important one is like, toward the end, the buyer actually receives control of the, not just the ordinal, like the actual account itself. Really, really, really cool. So I think this would be like a really fun hackathon thing if I were hacking personally. And then we're going to see more about this right after. But the chain abstraction demo, again, using OpenSea from Mintbase and chain signatures. And here's one part. So this actually, the README for the Mintbase thing is worth checking out. But this is one part that just shows, like, you literally just follow directions, run this, and it's just going to say, okay, now give me your OpenSea like NFT slug, and then it's going to use chain signatures to talk to that. Very cool. Okay, don't know where to start. Maybe I'm talking a lot about like concepts and whatnot. So the brass tacks is like, I would start there, Linktree / chain signatures. If we can get it to be chain siggy, that'd be fine. We don't have to. So if you want to do the decentralized front-end approach, then like kind of like the second one. And if you want to do just regular JavaScript, please. Then this top one is the one from Pagoda that I was mentioning. And then, of course, here, I give a little trophy to the Mint-based one as well, which is also like regular JavaScript. And yes, I think that's about it. I would say that like, if you want to get on some testnet Sepolia, this is like actually a really great link here. And developer docs are over there, Telegram group, and a bunch of us are here to help. Great.
Well, let's give a round of applause for Mike.